Hi, welcome back to Mind Maths with Amina. Today I'm going to solve the practice questions given in the study guide of Mathematics 1 given by University of London. Chapter 3 is differentiation, and the first question is to differentiate y is equals to 1 plus 2x minus ex and find when the derivative is equals to a 0. So the first, I'm going to take the derivative. The derivative of a constant is 0 because a constant does not change. 2x is a 2 and ex is a ex. And they want me to put it equals to a 0. So we have e power x is equals to a 0. So we can take the log to the base e on both sides. So ln e on the both sides, and according to the power law we can multiply x. The power is multiplied. Since ln e is simply log e to the base e, therefore it is equals to a 1. Hence we have an x is equals to a ln 2. So that's our answer. That's the value of x in which we have a critical point. Okay, the next question. We are asked to differentiate the following functions, and we're not asked to find any critical points or anything, so we just need to differentiate this. So the derivative of y with respect to x is we multiply the power. So the general rule is if you have a constant a, x power n, the derivative of y with respect to an x is going to be a multiplied by a n, x n minus a 1. And the general rule for when we have e to the power any function of x, then the derivative of y with respect to x is the derivative of f with respect to x, and then this function as it is. Okay, so using these rules for the first part, we have a 3x square plus the derivative of 3x square is a 6x, and then we write e 3x square as it is, and we're done. Okay, the next, we're going to use the quotient rule as a recall whenever you have a quotient with numerator u and v, and you want and you basically want to take the derivative of y, then you put the denominator as it is and the derivative of the numerator minus the numerator as it is into the derivative of the denominator over denominator square. So let's do this for part B. We keep the denominator as it is. So x square plus 3x plus 2 is written as it is, and we multiply it by the derivative of the numerator. So the derivative of 3x is just a 3, and the derivative of 5 is a 0. So there we have it. Minus numerator as it is. The numerator is a 3x plus 5, and the derivative of the denominator is going to be a 2x plus 3. And we are going to divide this through by the square of the denominator. So here you go. So the next step would be actually to simplify this. But if you do tend to make mistakes while simplifying equations, then I would suggest not to simplify it. Then just leave the answer here. I am going to, however, simplify it. We have a 3x square plus 3 3s are 9 plus 6 minus. We have a 3 2s are 6. X square plus 3 3s are 9. X plus a 10x. So we have a 19x plus 5 3s are 15. Okay, over the denominator stays the same, and it cannot be simplified further. Okay, we have a minus 3x square, and we have a 9 minus a 19 would be a minus 10, and then a 6 minus a 15 would be a minus 9 over the denominator as it is. And this is how far this is as much as you can simplify it. Okay, next part C. Part C is asking us to find the derivative of ln 3x square plus 3x plus 1 plus x power minus half. I want to avoid the quotient rule wherever I can, so that's why I'm just going to not write it as a quotient. I'm just going to write it as one numerator. Okay, as a recall, whenever you have a y ln and some function of x, for example in this case it's 3x square, then via the chain rule you're going to end up with dy by dx is going to be the derivative of f with respect to x. Let me just write it like this: the derivative of f with respect to x and fx in the denominator. Okay, so using this law, you must have already studied the chain rule, so I've used the chain rule to obtain this. Okay, so the derivative of y with respect to x, okay, so 3x square goes into the denominator as it is, and the derivative of this goes into the numerator, so the derivative is 6x, plus the derivative of 3x is just a 3, and the next we're going to multiply minus half, 1 plus x, minus half minus 1 is minus 1 by 3, and the derivative of 1 plus x is just simply a 1. Actually, let me write down this rule as well, that if you have y and you want to y fx power n, so according to the chain rule, when you want to take the derivative of y with respect to an x, you're going to multiply n, and fx power n comes as it is, but you have to multiply it with the derivative of fx. The derivative of fx in this question was a 1 plus x, and the derivative of this is simply a 1, so I don't need to just write multiplied by 1. That wouldn't look nice. Okay, now we just need to simplify it. The x cancels out, 3 1s are 3, 3 2s are 6. So we have a 2 over x, and let me rub this dot, I don't know, I put it there, plus 3 minus 1 over a 2, 1 plus x power 3 by 2. Okay, moving on to the next question. Okay, question 3.3 says, assume that the price demand relationship for a particular good is given by this. So the price demanded depending on quantity is 10 minus 0.005 Q, where P is the price per unit and Q is the quantity demanded per unit. Also assume that the fixed costs are 100 and the average costs are this. So total cost we know are going to be equals to fixed cost plus the variable cost, and they've given us the fixed cost as 100 and they're given us the average variable cost. Okay, so that's not the variable cost. Average variable cost is variable cost divided by quantity. So variable cost is going to be average variable cost into quantity, right? So average variable cost is a 4 plus 0.01 Q, and we need to multiply it by a Q to get variable cost. Okay, so therefore our variable cost is a 4Q plus 0.01 Q square. Okay, let me just make a box here. Also, the total revenue as a function of quantity, we know total revenue is price into quantity. So the price is given as 10 minus 0.05 Q. We need to multiply it by Q in order to find total revenue. So we have a 10 Q minus a 0.05 Q square, and therefore from this we can derive the profit function, which is total revenue minus total cost. Total revenue is a 10q minus 0.05q square, and total cost is 104q and 0.01q square. So that is what was required. Though this is just the profit. They want us to find the maximum profit. So if the profit function looks like this, what they're asking you is to find the value of quantity where this is maximum. As you can see that this happens when the derivative of the profit function is equals to a 0, and since this is a maximum point, we require the double derivative to be negative. Okay, so the profit function, what is it? Let's simplify it first. We have a 10 minus a 4 and a 0.05 plus a 0.01. So basically we have a 6q minus 0.06q square minus 100. Okay, so let's take the derivative of this and put it equals to 0. So the derivative with respect to quantity is a 6 minus 2 multiplied by a 0.06 is 0.12, 6 is 12, q and is equals to 0. So or x, let me see, 6, let me just multiply it in case I'm making a mistake. Did I do this right? 10q minus, there's a 0.05 and there's a, oh, I forgot a 0 here. We had a 0.005 here. 0.0. Let me make that correction first and then I'll multiply. Oh, then this number changes actually. Let me just erase this part. Okay, I had a 0.005 q square. So 0.005 plus a 0.01 is a 0.1. Okay, so this changes as well. I have a 0.5 q square here. So I'll have a 2 multiplied by 0.15 q is equals to a 0. So 2 multiplied by a 0.15 q is equals to a 6. 0.15 q is equals to 2 3 is 6. So therefore we have a 3 over a 0.15 and 3 divided by 0.15, 3 divided by 0.15, it's a 20. Okay, so I hope I got this right this time. Okay, actually I haven't, it says a 200, maybe I didn't divide it right. Oh yeah, again a silly mistake, there's a 0 here. Wait, we have a 2 multiplied by 0.015. See, whenever I'm rushing, I just make very silly mistakes. So it was actually a q is equals to 3 divided by a 0.015. And now this is a 200. Okay, good. So I label this as 200. And I need to verify if this is the maximum profit. So the double derivative is minus 2 into 0.1, which is basically 15 into 2 is a 30, right? So this is going to be a 0.03 and this is less than 0, hence we do have maximum profit. They wanted us to find the maximum profit. So the maximum profit is when quantity is 200. So 6 multiplied by 200 minus 0.015. I hope I don't do my stupid typo here again. Okay, so this is going to be the answer, and once we put it in the you'll just have to use a calculator to find this. Should I actually do this? Wait, 6 into a 200 is a 1200. 200 square is 40,000, multiplied by 0.015 is 600 minus 100. So 1200 minus 700. So that's the maximum profit is a 500. Okay, part B, hopefully I won't make mistakes now. What level of production is required to break even? So breaking even means that the profit is a 0. So it's called like getting normal profits. So the profit function being equals to a 0. So the profit function is this, and we want the profit to be equals to a 0, so we are breaking even. Okay, so we have a 0.015q, don't forget this anyhow, minus 6q plus 100 is equals to 0. Let's just use the quadratic formula, minus v plus minus b square, 6 squares are 36, minus 4 a c over 2a, and we have a 6 plus minus 36 minus a 6 over a 0.03, and therefore we have 6 plus minus under root 30, and we can write this as a 3 divided by 100, right? So overall our answer is just 100 over a 3 into a 6 plus minus under root 30. Okay, since under root 30 is actually less than 6, because 6 are 36, right? So if I square it, so this holds, right? So it means that there can be two possible solutions. So there are 2 points, there are 2 quantities in which profit is going to break even. So the first quantity is 100 over 3, 6 plus under root 30. You can calculate this using your calculator, and the next one, both are positive quantities, greater than 0, 6 minus under root 3, under root 30 I meant, is so there are 2 positive solutions, and I think that he's not going to reach, if he starts making normal profits here, then why produce this, why produce higher quantity, why produce higher when you can get normal profits at lower? So we are going to say that this is going to be the break even point, because there's no point in producing a higher quantity when you can get normal profits at a lower quantity. Why waste resources? Okay, part C of this question. What are the marginal cost and marginal revenue functions? This is an easy one. We've already written down the total cost function, which is this. Hopefully there is no typo here. The marginal cost is just the derivative of total cost with respect to quantity. So it's going to be a 4 plus 0.02 Q. And the total revenue was a 10 Q minus 0.05 Q square. minus a 0.05. See, I keep making this, I keep getting 1 0. Now this is triggering me. Marginal revenue is equals to derivative of total revenue over quantity. So this is a 10 minus 0.01 Q. Yeah, that's it. That solves all three parts of this question. Okay, so I'll just do 4 questions in this video, so it's not that the video isn't that long. The demand function relating price and quantity for a particular product is given by this. So P is equals to 5E minus half into an X. X by 2 is minus half multiplied by X. Okay. Find the production which will maximize total revenue. Okay. So the total revenue is price into quantity. So quantity is being represented by X here. So I'll just write a P, I'll write the X later. Okay, into an X. So we have a 5xe minus half X. And we want to find, maximize the revenue. Since these are two functions of X being multiplied, we'll have to use the product rule. As a revision, where whenever you have y, which is function of two variables also depending on x being multiplied, then the derivative of y with respect to x is u as it is, derivative of v with respect to x, then v as it is, and the derivative of u with respect to x. So basically they take turns. So whenever we want to take the derivative of total revenue with respect to x, 5 is a constant, I can ignore it, take it outside. So x as it is into the derivative of e minus half x, and that is going to be, the derivative of minus half x is simply a minus half, and the function e minus half x remains as it is. Okay, plus then e minus half x as it is into the derivative of x, which is simply a 1. Okay, so opening this up, we have a 5 minus minus x e minus half x over 2 plus e minus half x. Okay, so we want to maximize total revenue, so that means we have to take the derivative with respect to x and put it equals to a 0. When we do that, I have this expression, 5 is not equals to a 0, right? So that means this expression will have to be equals to a 0. So if I take e minus half x out as common, and we'll have a minus x over a 2 plus a 1 is equals to a 0. Remember the graph of ex and e minus x. So e minus x and e plus x, basically they lie everywhere above the x-axis. So whether it's a positive value or a negative power, it's always going to be greater than 0. So this expression cannot be equals to a 0. So e minus half x cannot be equals to a 0. So the only way that derivative is going to be equals to a 0 is when a half into minus x is equals to a 0. So solving this, we have a minus x over 2 plus 1 is equals to a 0. So x by 2 is equals to a 1. Therefore, the quantity at which total revenue is being maximized is a 2. Okay, we've done this part. And they wanted us to state the resulting total revenue. Okay, that's easy enough, because total revenue was a 5x e minus half x, and the value of x is 2, the 5 2s are 10, E minus 2 over 2 is just a 1. So therefore the total revenue, which is maximum, the maximum level of total revenue is 10 over E. Okay, lastly, they want us to produce a rough sketch of the marginal revenue function. Okay, so the marginal revenue function is given as, we calculated it over here. This is the marginal revenue. Okay. And what we can do is, we can take E minus half x as common, so that we are left with x minus x over 2 plus a 1. Let's find out the intercepts. When x is equals to a 0, we have a marginal revenue is equals to 5 e power 0, and then we have a 0 plus a 1, right? So actually we can also write this as 5 over 2. But answer should be same, so I don't know, I don't think it matters. Let me see. We can write it as 5 over 2, and we can basically just take the LCM. So E minus half x, and then we have minus x plus a 2. Okay, so putting the value of x is equals to a 0, we have a 5 over 2 e power 0, and then we have a 0 plus a 2, so we have 5 over 2 e power 0 is a 1, and we have a 2 here, so the answer is a 5. Okay, and whenever marginal revenue is equals to a 0, we have this whole expression equals to a 0. And since 5 over 2 is not equals to a 0, this is not equals to a 0, the solution that we get is x being equals to a 2. So now we have our intercepts, and we can also see limiting behavior, that when the limit of marginal revenue as x approaches 0 is going to be, when we substitute 0 in this, we are left with 5. So the marginal revenue approaches 5. However, if we take the limit of marginal revenue as x approaches infinity, we can't really solve this limit with the limited knowledge we have, because 5 by 2 into this is basically going to approach a 0, and this is going to approach a negative infinitely, and you can't basically say a 0, conclude what a 0 multiplied by negative infinitely is. This can be solved using the L'Hopital rule, but that is outside the scope of this course. So we're just going to leave this here. This is, you can't calculate it given the knowledge that is in the course. So we are going to ignore this. But what we can guess is that the marginal revenue must look something like this. We have, when x is equals to 2, marginal revenue is equals to 0, and when x is equals to 0, marginal revenue is equals to a 5. So we can predict this being a negatively sloped curve. Okay. This is enough for this lesson. I will continue solving the practice questions in the next video, and apologies for constantly writing, what was it, 0.005 as a 0.05. I think I'm just like, it's hard for me to see that there's a decimal place right there. Anyhow, see you in the next lesson. Take care.